So let's talk about, so today, obviously last month we did a workshop on a very basic WWHM workshop, right? Just talking about what it's about, what it was trying to accomplish, and going through some basic modeling scenarios. That whole workshop is actually on our YouTube channel. So if you search Clear Creek Solutions, you can find that workshop if you want to see. It was about 50 minutes of material there. Like I said, I'll be admitting people as I go here. Let's keep that window right there, maybe. So you can find that one. I'll probably link it eventually here. But this workshop, we're talking about the commercial elements that we have in WWHM 2012. And the reason they're not packaged with the free version of WWHM 2012 is technically it is a government or public funded software package, so we can't include commercial sponsored products in a government sponsored software. But there's an easy way to enable these commercial elements in WWHM 2012, and that's what I'm going to go over, as well as what their purposes are and then how we can model some of them. So that's what we're going to go over here. Just quickly on Clear Creek Solutions, we were founded in 2005 by Joe Brasher and Doug Byerline. And we specialize in hydrology, software development, modeling. There's 60 plus years of experience between those senior members. And then, of course, we developed WWHM 2012, as well as many other software packages that are used along the West Coast and across the country. I just want to make sure that I can see this window while I'm doing this. Okay. So I went over some of this in the previous workshop, but WWHM 2012 is a continuous simulation software package. If you have questions about that, you can leave that down below. So HSPF is what is powering WWHM 2012, and then that's what's used to model the stormwater facilities, perform the water quality analysis, and uses the 60 plus years of available rainfall data, as well as the 15-minute time steps. And we've actually gotten some questions on people asking when the rainfall data is going to be updated, because I think it goes all the way up to 2012. And in short, it is very complicated, and it's quite an involved process to add new years of rainfall data to a software, and it also involves coordination with the Department of Ecology. So there's definitely talks about that, but it's quite an involved process. It's not as simple as just importing some new data into the software. Okay, we're going to talk about commercial elements here. So in this box in WWHM 2012, when you open up any of your scenarios, if you have commercial elements activated, they'll be right here in the bottom left. If you don't have commercial elements activated, you won't see anything there. And so that's what we're going over. And so I'm going to show you how to activate these commercial elements first off. So there's 9 right now in the commercial toolbox for WWHM 2012. And I'm going to show you from scratch how I would do this. So I'm going to share my screen. Oh, here we go. Sorry. Sorry about that. My PowerPoint closed out, seeing who need to be invited. So now you're in here. Just to review real quick, I'm going to show you how to set up and activate the commercial elements in WWHM 2012. So here we go. I'm going to stop sharing that screen. What I'm going to share now is actually, okay, so here's my web browser. Everyone should be able to see this. If you go to so here's my web browser here. To get the commercial elements, first thing we're going to do is go to downloads. And obviously, if you don't have WWHM 2012 yet, you're going to want to download that first, as well as the map pack, but I'm assuming you already have that. So here we go. Here are the instructions to download the commercial elements, and it's a little confusing, so I'll go over how to do it step by step. The first thing you're going to want to do is click the download button here, and you can just click it or open link in new tab, and it gives you these instructions. I think it's a little overcomplicated, so I'll help to simplify it here. But basically what you're going to want to do is open up a notepad file. So I'm just going to go to my computer here. I think basically all Windows systems at this point have some form of notepad. So here's my notepad. Oops, So here's my notepad here. And what you're going to do is you're going to copy this text into it. Options commercial equals true. You can copy and paste that into this blank notepad file. So now you have this notepad file. And the next thing you're going to do is you're going to save it in this program data directory where wwhm 2012 is located. Now here's a quick tip when it comes to Windows. For Windows 7, 8, 10, all the way up through 11, they actually hide this directory here, this program C program data directory. And so if you don't see that, then you won't be able to move this file in there. And so what I'm going to show you is hopefully you can see my Windows screen. Let's see. Sometimes Teams does funky stuff. And I'll invite this person in here. Okay, I just want to share. Okay, now I'm sharing my entire screen. Sorry about that. Okay, so now we have this text here copied from the options commercial equals true into a notepad that we got from this download file here right on the Clear Creek Solutions website. And so that's there. Now we need to find that program C data directory. And maybe some of you already have it unhidden. Great. Maybe some of you don't understand how to do that. So all you're going to want to go to here is the control panel. And let's see, you're going to want to do appearance and personalization right here. And I'm on Windows 10, by the way. Although Windows 10 and 11 are pretty similar. Then you want to click show hidden files and folders over here. And right here, you're going to get this file explorer option. And it says hidden files and folders. The default in Windows right now is don't show hidden files, folders, or drives. And so you're not going to be able to see that C drive. What you want to do is click show hidden files, folders, and drives, and then you'll be able to find that C drive. So that's a really important part there. Make sure that is selected. And then what you're going to do, let me go to my file explorer, click on your Windows C drive right here. Program data right here. You can see it's kind of like lined out because it's not, usually Windows doesn't let you see it. You want to go to wwhm 2012, the data folder. And then as you can see, I already have the notepad file here, so I'm not going to do it again. But I would go file, save as, and then I would save it in that location as options.dat file. And what this is just telling the program to do is commercial equals true or activate the commercial elements. And then I'm going to put that file in that program data folder. So you can see it's already here for me, options commercial equals true. So I know that it's quite a lot of steps to do that, but it has to be set up this way for a number of reasons. Let's see, how do I... There we go. Let me share my screen. Don't worry, I'm sharing the screen again. Okay. Did anyone have any questions on that process? Or they probably want me to get to talking about the elements. But a part of this workshop was discussing how to set that up. But real quick, you're just going to click the download, open here, copy this portion into a notepad file, find your C drive, your program data, wwhm 2012 data, and then save it as options.dat there. Okay, I hope everyone's got that down. This workshop will be saved and it will go out again, so you'll be able to review these instructions. And there's also a very handy, we try to do our best to help people with this. There's also a short video on how to do it on the website already. So if you want to watch that, that'll also help you do that. You're probably tired of this already, but there we go. That's how we do that portion. And so that's how you can activate them. I take you through that a little bit, but let's talk about what commercial elements are in wwhm 2012. So we're back to the PowerPoint. So we went all through that aspects there. And so the commercial elements that we are able to add to wwhm 2012 just give people obviously more options when it comes to their modeling, and then allows them to use real world devices that are used in stormwater design, and then make it a part of their wwhm 2012 design. So we feel it's very handy, and companies like to make it easy for the user to use it and design it. And so essentially the companies will come to us with these products and say, here's the specs for it. Can you model it and design it? And then our team of developers will replicate what it does in the real world in the model, which is basically kind of the concept behind wwhm 2012, is to best simulate what's going on in the real world with our elements. So first one we're going to go over is the Filtera element here, which is the one on the top left. And now a lot of this information has been pulled from these companies' websites, and so if it sounds almost like a sales pitch, it's just from their website. But I'm just trying to give you a good idea of what each of these elements can do. So the Filtera element is similar to like a bioretention facility in terms of its function, but it can also be optimized for that high volume and flow treatment and some of that pollutant removal. It's very adjustable. There's a lot of different Filtera modules that come in the software that you can play around with that allow you to help filter the water coming through your system. The next one is the storm capture element, and this is just a stormwater detention style facility and a vault that helps mitigate that rainwater runoff to prevent flooding and of course the erosive flows in urban and suburban developments. And so this second paragraph is a little bit sales pitchy, but you get the idea. A groundwater infiltration system for LID and a stormwater treatment system. So that's what Oldcastle does. And then this is the StormTech element. Very similar. It's a like I said, it's primarily used under parking lots actually, and it's used for stormwater storage. There's many different ways you can modify the chambers in the StormTech element, and it can be used with other green infrastructure and things like that, but mostly used as stormwater storage, and a lot of the times underground underneath those large lots and things like that. This is the Brentwood Element, and they have a lot of different series and modules that you can use, but it's also another subsurface storage unit and to help store your water. There's just different sort of features that come with each one of these elements, but a lot of them are for standard stormwater storage. Now this MWS is it's a biofiltration system, and then it's using a horizontal flow, and that I guess that allows for a smaller footprint and a higher treatment capacity of the water. And it can also be used to design for the storage of additional volume control, although mostly I would say we use it for something like biofiltration, but it can also be used for that as well. This is the Maxwell element, and this drive rail receives inflow through a graded opening on the top of a chamber, and then can be directed through piping connections and then into drywall. I haven't used this element a ton, but that's kind of a description of it. The Coltec element, this is the best information I can find. I think in wwhm 2012, in each of these elements, when you import them and add them, there's links to the websites where you can learn more about the elements there. And of course, you could probably just contact the people and they can tell you everything you need to know about these elements. But it's another stormwater chamber style element here. The Coltec CMP, it's a corrugated metal pipe, and can be a go-to material for those detention and infiltration projects. Just another way to do that. Then the Urban Pond is a concrete underground storage system. And you can modify the modules quite a bit, how many different ones there are, how many rows, and its area. So it's another one of those underground stormwater management ones. So I'm going to do a modeling a little bit here, but if you have any questions about anything, you can leave them in the chat now, and I can help you out with that. But I am going to flip over to wwhm 2012. Seems like no one has any questions, so I think that's good. I think I'm doing a good job. Doing an okay job then. Let's model a few of these just to show you the process a little bit here. So I'm going to start in King County, and then this little patch right here just happens to be SeaTac Airport and has a precip factor of 1.0. And I had someone ask the other day, how do we account for precipitation, right, or our precipitation data, if the rain gauge is covering a large area like this? Like the SeaTac gauge is covering quite a bit of area, as you can see. Now we're getting out to Landsberg here, but the elevation and the wind and the distance to the sea, obviously that's going to have an impact on the precipitation. That's why we have the precipitation factor. That's what's accounting for all those changes in the rain gauge data as it moves along the county. So that's just a little background on how that works. But if we go to the schematic here, I'm going to do a pretty simple scenario here. So let's drop in the basin. We're going to do 1 acre or 2 acres of sea forest flat. I'll connect that to the point of compliance and run the scenario. And if any of this stuff is, you want to learn more about the basics, we actually have a free WWHM 2012 course. It's a 10 video course that teaches you how to use it. And that one's 100% free. You can find it on our website. And of course, we have more levels of detailed training. So that's the pre-developed scenario. I'm going to go to the mitigated. And what I want to test out here is this Filterra element first. So here's the Filterra element. We're going to add this to our project. As you can see here, there's quite a bit of modules. Well, the first thing I'm going to do is put in my mitigated area. So we'll go 1 acre sea lawn flat, and we'll go 1 acre of roads flat. Let's connect it. Let's connect this element to the Filterra. We'll connect it to the point of compliance here. Okay, so there's a lot of options with this Filterra element. You can do an FTIBC configuration or FTPD configuration. They're just slightly different variations of each other. Obviously, you can follow the link and learn more about that Filterra element, or you can do a completely user-defined module here. So you have quite a few options. What I'm going to do is the FTPD configuration here, and there's a lot of models. And all these are just going to do is help you account for whatever water volume you have. So if you have a really large project site, you're going to need a different, probably larger Filterra model than if you had a smaller project site. Right now we got 1 acre of impervious. That's decently sized considering it's going to a bioretention LID type facility. But what I'm going to start with is, let's start with something simple, the FTPD 0710, and you can also modify the media filter rate here in inches per hour. And obviously the higher it is, the more water it's going to be able to filter, the better it's going to be able to do at treating it. The lower it is, the much tougher it's going to be. So it does let you modify that. I'm going to leave it at 50, which is it's pretty decently high, but for media filter rate, not too out of the ordinary. I think that it's actually pretty good. So what I'm going to do is run this scenario. When you run the scenario, it's going to give you some of these results down here. So total volume filtered in acre feet, the total volume through the pass by, the total water volume, and then that percent filter, which is the most important one that we want to talk about. Talked about in the previous workshop in terms of the Department of Ecology's minimum requirements. One of them can include that water quality percent filter mark is one of the minimum requirements, or can be one of the minimum requirements for your stormwater project. And the specification we're trying to meet is 91%, and so this blows right past it. 97.26%, it would easily meet the requirement for your project. However, if we went to the analysis tab here, we looked at point of compliance 1, right? So we know it's treating the water, but is it accounting for the erosive flows? Well, that's another question, right? So if we take a quick look actually and we see what's going on, we can see that this facility it's treating the water, right, 97%, but it's definitely not passing the flow duration standard, right, not even close. And that's sort of the game you play with some of these facilities that will treat the water. And then detention facilities, obviously detention facilities, their purpose is to meet the flow duration standard, right, and keep all that erosive flow from occurring, but it's not really treating the water, right? Then something like a Filterra element, it does a good job of treating the water, but it's tougher to account for these super high volumes or these super high flows to prevent the erosive flows. So that's the back and forth game that you're gonna play with this. Now, let's see what we do when we lower the media filter rate. I just want to show you what this does. So we went to 30 inches per hour, pretty big reduction. If we ran the scenario here, let's take a look what happens to the percent filter, just to give you an idea of how this facility will act. Not that it's a necessarily linear relationship. Many people think that You know, these facilities are very simple to model in the program. They're not. It's very complex. We're using things like the Van Newton equation and many other equations to study how the water is moving through these different layers of media. These different layers of media. If you look at the standard, like Washington Department of Ecology, or the bioretention facility that we have in the software, modeling how the water interacts between these three soil layers is incredibly complicated. And it's not something you can sort of work out in a spreadsheet and then come back and say, well, this is how you did it. It's actually a quite in-depth process. And it's very similar for any of these other elements that involve media filtration rate. So we lowered it to 30 inches per hour, and you can see that reduced the percent filtered by close to 40%, just to give you an idea of how this facility acts. Now, if we put in a much larger facility here, let's go to, or actually, I don't know if it's necessarily sorted by size, but by more like type. If we go 8105 here and we ran the scenario, we can see how this facility reacts to the volume of water that it's getting. And so what's really useful is that filter storage by volume at bypass. You can see here, you can also open the table to see how the facility is reacting across its entire volume. That's a really good tip, to use that open table over there. But I'm curious to see how this facility will react when we change models, obviously. So in this one, was able to filter 98% of the water. I'm also curious about the flow duration standard. So I'm going to look at point of compliance 1 there too, and then I'll show you. I think this facility will also fail the flow duration standard, and then I'll show you how maybe we can meet that. What a good tip would be. So it also failed quite a bit. None of the flows passed. So what we would do is, now that we know that this is filtering correctly, and maybe you could even change the models so that you could use a smaller model. You just have to look at their different model descriptions to best fit your facility. Once you know you got that 91% filtered, disconnect point of compliance, and you're still trying to meet the flow duration standard, you could add in something like a pond or a vault facility or something like that, or a tank facility, and then attach it downstream of this Filterra element, and then do something like an auto pond situation. I'm not going to run auto pond because it takes about 10 minutes, and we've gone over that many times. But you could run auto pond and meet that flow duration standard. So that would be a good tip for that. Like I said before, the Filterra element, yes, it is different than a bioretention facility, but some of the same principles apply in terms of trying to filter the water to meet that 91% when you size for water quality. Okay, I know it needs to be sized for point of compliance, but when you're trying to size for water quality, we also have a course on how to model bioretention facilities. So if you're looking at more in depth on how to everything relating to what's in a bioretention facility, what are some of the principles behind it, and then how to model quite a few advanced situations, we go pretty in depth in that course on how to model bioretention. You can check that course out as well. So that's the Filterra element. What I'm gonna do here, let's model something else. Now, with some of these other elements here, like mostly these elements are flow control. So the storm capture, the storm tech, the Brentwood, right? It's gonna come down to which model you choose, and then mostly comes down to running the auto sizing feature, unless you have a kind of a specific scenario that you're working with. For example, with the storm capture element here. Oops. Connect to element here. Let's connect to point of compliance again, obviously. So with this element, you can go quick storm capture. You can also choose some of these facility dimensions here based on the models that they have. So this is a 45-foot length, and it goes all the way up to 15,000 feet, right? Just depending on your project. And it shows you the number of storm capture units that you're using, and then the total length of those storm capture units. And so what you want to do here actually is change this effective depth to be higher than that riser height. So I'm going to change the effective depth to 7, and I'm gonna have infiltration off for now. You can enable infiltration, but obviously the design process gets quite more complicated when you enable infiltration. So you know what, I'm just gonna run this. I'm just gonna see what happens. And so there's two approaches you can take when you're modeling with these elements. Is you can change and swap out the type of facility that you're using in the model, and then run the scenario and test it to see if you're meeting that flow duration. Or you can use the auto size facility and it'll do it for you. Obviously both have their pluses and minuses. With something like a auto storm capture, it'll do it for you, but you might not get results that fit your project constraints. It just really depends. Or you can do it manually, which can take a long time because it's a long iterative process. And like I said, modeling these elements and getting them to work right and meet that flow duration standard, it's not so easy when doing it by hand sometimes. So if we look at point of compliance here, let's see how well I guessed. Now our facilities, or our mitigated area, is pretty small, 2 acres. Nothing too crazy. However, our facility's not that big either, so I don't suspect that it'll pass. So if we look here, it did fail. You could say, okay, well, maybe we could add some length. You know, if we went to 105 or 195, you see it right off the bat, it was we needed 13 storm capture units, and then the total length was at 195, and then you could run it and check back. So that's sort of the approach that you take with these elements. Auto storm capture will get you a automatically sized facility. I'm not going to run through that because you'll just sit and watch me as this screen moves and the graphs sort of meet up, right? It is interesting to talk about, but I don't need to show you that again. We've done that before. So that's the storm capture element. With the storm tech, similar idea in terms of it being a mitigation facility. However, there's many of these facilities, and it's likely going to be more of a chamber water storage system for these events, and then you get to choose the chamber model that you want to use. It just depends on the size of your project, right? Quick chamber just fills in these values real quick, not doing any sort of modeling, but you have quite a lot to work with here, including the row length, the number of chambers that you're going to have, the number of end caps, that total top stone and then bottom stone depth, and of course enabling infiltration for a whole nother fun layer of complexity to this. But for a project like this, I would use the auto chamber. I just ran quick chamber. I'll run the scenario just to show you how this facility performs right off the bat, but I would encourage you to maybe experiment with that on your own to see if it works for you. It all depends on your modeling scenario, right? What are your constraints and what are you trying to accomplish? And then some of these obviously could be used in a situation where you have your runoff area going to some sort of filtration system and then to a stormwater detention system. You could have that on the back end as well. That could really work well. So if we looked at the point of compliance, and this is all stream protection duration. The LID duration is a different kind of duration, and we'll probably do a future workshop on what that means. But right now it's all stream protection duration, which I went over in the first workshop, what stream protection duration means and why it's important. But if we look here to see how the facility performs, I actually don't know. Yeah, it will fail. We're probably going to need more of these facilities to make it work. So that is the StormTech element real quick. The Brentwood is similar. There's a module you select with quite a few different heights, and then you're kind of going to run auto module most likely to get that facility size properly. This one's a little different. This is it's maybe more similar in the vein to the Filtera element, where we're modeling for water quality again. And so there's quite a few models to choose from. And so what was interesting when I looked at the PowerPoint is it could also be used for flow duration or to handle those high volume flows. So I wonder if I picked an element here, how well this will react in terms of stream protection duration compared to maybe the Filterra element or the standard bioretention facility. We also have to note that this is at 25 inches per hour media filter rate. The default for the Filterra element was 50. So that's just interesting to note here. And this will do an automatic facility sizing. But what I'm going to do is run the scenario again. Let's see what percent filter we get for one of these MWS elements, and then we'll see what it looks like for the flow duration standard. Okay, so filtered 100% of the water, so maybe overdoing it a little bit with this facility. It's quite a bit. Now I'm interested to see what the flow duration standard looks like for this facility. So this shows you how difficult it can be to meet the flow duration standard for one of these water quality treatment facilities. Because obviously it had plenty of media to filter literally all the water, but not enough to keep it from the erosive flows. So that's interesting. Play around with that element. This is similar, another storage element here. There's quite a few factors here. So we have basically, this is a set element, and so they want you to contact them before changing any of these parameters here, because this is the set element. This is what it does, and either it's going to work for your facility or not, and you can modify the infiltration rate there. So pretty straightforward on that one. The Coltec here, it's similar to what we're doing with the StormTech. You select a model, it spits out these row lengths here. You can go quick chamber real quick and see if that one works for you there. So very similar to that one. Not gonna waste your time if it's very similar. This one's a little different. You can a little more modification there. You can add manifolds to this. Do a quick CMP and model. Pretty straightforward there. And then this is the urban pond element, and this one's a little trickier to design actually. What you're going to want to do is develop a required volume. Whoops. Let's see, where did I go? Now we're back. Run it to get a required volume, and then you're able to use auto design for the facility, and then it'll develop all these factors here. You can also choose the inside height to model that facility appropriately. So obviously you can go to all these the websites here for all these different elements, and you can learn more about them, see if they're good for your designs obviously, and then put them in the model and see if they are what you need. But that's kind of the basis behind the commercial toolbox. I think what I'll do in a future workshop is we'll go over these pro elements here, because people have questions, especially about the CAVS element, and the bioretention is also a big one. People have a lot of questions about that. But that's all I kind of had intended, was to go over these different commercial elements. If anyone has any questions about anything modeling related, they can drop it down in the chat, and I'll do my best to answer. If you were at the previous workshop and I didn't give you the best answer that I could, you just email our team, and then we'll give you a concise answer on that, because usually when I consult with the developers, we can give you a really good answer on that. But if anyone has any questions, let me go back. Let me go full screen here. Yeah, if anyone has any questions, they can drop it into the chat. I will add a few links of my own here. This is one for, and some of you have already taken this, which is awesome. This is the wwhm Academy. It's our paid for wwhm training course. Doug Byerline, basically, Doug Byerline does a few workshops per year that are live, but this is basically one of his workshops, but you can access it through our website at any time and review the material. That's a very useful resource to have at your disposal. A recently released course that we put out was called the Bioretention Masterclass, and this, like I said before, takes you through everything regarding bioretention modeling from start to finish on that. So if you don't have a good idea how to model bioretention, this course is an excellent resource. We give you practice projects to work with. We feel it's a pretty good resource for learning that. And then of course, we understand, so we want to give people a chance to learn WWHM no matter what. So this is our free WWHM course to get you started with it, and that takes you from the very beginning. So that's also a good resource there. We just want to help people learn the best as possible, and same thing with these free workshops. So I'll stick around a few minutes if anyone has any questions about anything modeling related, but other than that, that's basically all I had planned. It doesn't have to be on commercial elements. We can go through anything, but that was sort of the basic idea. Let's see. I'm outside of my screen share there. Okay, it doesn't look like anyone has any questions, so thank you all for attending. If you have any questions, just hit up the support email on the website, and we'll be happy to help you out. But thank you for attending, and we'll see you guys in hopefully the next live workshop.